Okay, so next question. There are two goods, newspapers and coffee, and two people, Rory and Lorelei, in my model economy. Lorelei can make coffee faster than Rory. What can we definitively say about their comparative advantage in each good and absolute advantage in each good, if anything? Okay, so the resource is time in this case, and Lorelei can make coffee faster than Rory. She can do more with her time in terms of coffee than Rory. So we can say for sure that Lorelei has absolute advantage in coffee. Okay, so if I gave you the problem, if I phrase it another way, Lorelei can do X cups per hour and Y newspapers per hour, and Rory can do A cups per hour and B newspapers per hour. Okay, and I said that X is greater than A, so Lorelei then makes, that's another way of saying Lorelei makes more coffee per hour, right? That means X is greater than A, okay? And if X is greater than A, that means Lorelei has absolute advantage in coffee, okay? What does that mean about newspapers? Who has absolute advantage in newspapers? If Y is greater than B, right, that means Lorelei would. If Y is less than B, Rory would. What do you know about Y and B? Who makes more newspapers per hour? You know nothing. There's nothing in that statement that says that Lorelei makes newspapers faster than Rory, or that Rory makes newspapers faster than Lorelei. So that's a big old question mark. We don't know who has absolute advantage. We don't know who has absolute advantage in newspapers. Okay. What do we know about comparative advantage? Okay, let's bring this up a little bit. Okay, so do we know X and Y versus, is it greater than, equal to, or less than A over B? Okay. Another way of saying that is, does Lorelei give up more cups per newspaper than Rory gives up cups per newspaper? Okay, if X divided by Y is greater than A divided by B, that means that Lorelei has higher opportunity cost in newspapers. Okay, she gives up more cups per newspaper, meaning she has comparative advantage in coffee. Sorry. Okay, so we would need to know if X divided by Y is greater than, less than, or equal to A divided by B. If it's greater than, then we say Lorelei has comparative advantage in coffee. If it's less than, so if Lorelei has comparative advantage in coffee, then we can say Rory has in comparative advantage in newspapers. And if X divided by Y is less than A divided by B, then Lorelei has comp in the other one, now newspapers, and Rory in coffee. But we don't know X divided by Y or A divided by B either. The only thing that we know is that X is greater than A. Okay, that's all we know. So we can't say anything about x divided by y or a divided by b. We can't say anything about if y is greater than or equal to b. We just don't know it. All we can say for sure is that Lorelei has absolute advantage in coffee. All right. So next point, suppose I said that Rory has a lower opportunity cost in writing newspapers and that this economy is at the point of complete specialization. Okay. In words, describe what it means to be at the point of complete specialization in this economy. What determines who produces what? So the answer I was really looking for is, so we know that Rory has lower opportunity cost in writing newspapers. To have lower opportunity cost means that she has comparative advantage in newspapers. Okay. So we know that, therefore, Lorelei has comparative advantage in coffee. So in this economy, what being at the point of complete specialization means is that Rory spends all of her time on newspapers, Lorelei spends all of her time on coffee. If you gave me the definition of complete specialization, I took it, if you said the person does the thing that they have comparative advantage in, I was really looking for you to take it one step further, but the way the question's worded, I could see it making sense the way some people have answered it. What determines who produces what? Opportunity cost, or you could say comparative advantage. Okay, so Rory has a lower opportunity cost in writing newspapers. Another way of saying that, she's comparative advantage in writing newspapers, therefore she writes the newspapers. Okay, I don't know if that's how it actually pans out in Gilmore Girls. Someone told me to do a Gilmore Girls one last year when they filled out their questionnaire, so I'm like, all right, I'll throw in a Gilmore Girls question there. All right. So here we go. Here's another Always Sunny question, and more importantly, another trade question. So y'all have seen these a couple times now, and you should be pretty familiar with it. I noticed a few people made the same mistakes on quantitative assessment 1, and then for those that did the review extra credit, they copied those mistakes over. Not the same. It's not that they copied and pasted the answer key, but they retained those same mistakes. And then when they did the midterm, they had those same mistakes. I expect you to kind of progress as it goes. So it's okay. Like on the first quantitative assignment, you didn't understand it. It's tough, and maybe there's some places where I could do better. But once the answer key's out, I expect you to study the answer key. If you had trouble, solve through it again, and really kind of work through the things that you're not understanding. And I'm imagining if you're watching this video, you're already doing that, and maybe this is a pointless message for you. But if you are watching this and you haven't solved through the homeworks, whenever there's a homework, I post the quantitative assignments. I post the solutions, the day after, almost immediately. I have them like ready to go, and I'm just waiting for the assignments to come in, and then once the due date's done, it should automatically populate. So check the answers; they're always up on Blackboard, and it not that if you're close the first time and you have the same mistakes, it's like whatever, but like it does bug me a little bit because you're just not piecing together one particular part. And you can ask me. I do the office hours for a reason, so that you guys can engage me in the questions you have. So if something's not clicking, I don't want it to continue not clicking when you leave this course. I want even if you don't get it right the first time, progress. But that being said, that's on you. I'm going to grade you for the work that you that you write down. I can't grade you more beneficially or less beneficially because you stayed stagnant or you progressed. So just the work is on you to understand that. Just know that when I see the same mistakes repeated by the same people over and over again, it's like, that sucks. All right. Just ask me questions. That's all. Okay. Okay. So Charlie and Dennis manage a local bar, and they have different capabilities. Charlie's 100 rats. Charlie is 100 rats per hour and 55 drinks. Dennis is 75 rats, 75 drinks. Hopefully that kind of made things a little simpler for you. Because Dennis's opportunity cost was 1. So that should, kind of simplify things a little bit. All right. So let's do this. Graph. So first I say they're PPS. I give you rats and drinks on the Y and X axis. And then it's a linear PPF. Everything in this course has been a linear PPF, so it should be a line. And I just want, because it's constant opportunity cost, and I just want the intercepts basically. And I want you to label that it's Charlie. So let's start with Charlie. So this should be 100 rats. And if he spends all of his time on drinks, it'd be 55 drinks. Okay. Dennis. $75 drinks. 75 rats. And D for Dennis. Yeah, that's it. That's really all there is to it. So it's the most drinks that he can do and the most rats that each person can do. Okay. So if Charlie spent all of his time bashing rats, he'd get 100. Charlie spent all of his time making drinks, he'd get 55. Same thing with Dennis. All right, then I asked you to fill in the chart with each person's opportunity cost. Oh, what did I just do there? All right, I'm just going to do this right here. It's a lot easier to do it on here than recreate the graph. All right, so what did I say? Charlie does 155. 100. I guess I do want him split screen after all. All right, so what's Charlie's opportunity cost for 1 rat? So he gives out 55 drinks per 100 rats. So it should be 0.55. Okay. His opportunity cost for 1 drink will be the reciprocal. He gives up 100 drinks for every 55 rats. So it should be 1.818. I just remember that number. But it would be 100 divided by 55. You want to test it. Bring over my calculator. 100 divided by 55 is 1.818. All right. Where did my calculator? I'm going to close that. Oh. Okay. So Charlie's opportunity cost for 1 drink is 1.818 rats. And if you're confused about what's the numerator and one denominator, basically this is saying Charlie gives up more rats per drink than he gives up drinks per rat because it's greater than 1. He gives up close to 2 rats per drink, which makes sense because he makes 100 or bashes 100 rats for every 55 drinks. Dennis is easy. Dennis gives up 1 rat and 1 drink for whatever the opposite good is. Okay. All right, so who has comparative advantage and absolute advantage in each service? So who has a lower opportunity cost than rats? 0.55 is less than 1. So Charlie has a lower opportunity cost in rats. Okay, let's do, so he has comparative advantage in rats because having lower opportunity cost means you have comparative advantage. Dennis, therefore, must have comparative advantage in drink serving. Okay, you can only have comparative advantage in 1 good when there's 2 people, 2 goods. Okay, so Dennis has to have comparative advantage in drink serving. another way to think about that is, all right, so Dennis does 75 and 75, Charlie does 155. So if you gave Dennis rats or drinks, doesn't really matter. Like he's got opportunity cost of 1. He's equally equipped to do both. But Charlie clearly does rats better than he does drinks. So Charlie must have comparative advantage in rats, right? If Dennis is equally skilled at both and Charlie's better at one, then you'd want to give Charlie the thing that he's better at, right? That's just like how you can think about that like logically. So absolute advantage is just who does more of the good given the time. Charlie bashes 100 rats to Dennis's 75, so Charlie has absolute advantage in rats. Dennis bashes or makes 75 drinks, so Dennis has absolute advantage in drinks. All right. Next up, draw the combined PPF for Charlie and Dennis. Label the intercepts, points of complete specialization, and slope. So those are the only 3 points you need for a combined PPF. We'll call it a joint for combined, joint or combined. Should always be this shape. Okay. So this is the point of complete specialization. Sorry, it should always be this shape when you have constant opportunity cost for each person. Okay. Point of complete specialization. This is one of the intercepts. This is the rat intercept. If they spend all their time on rats. This is if they spend all their time on drinks. Okay. So this is what it should look like, but I want the points, obviously. Before I even do the points, though, let's do the slopes, because I want to kind of get you guys in the habit of thinking about these graphs intuitively. Okay. So the slope is going to be, so imagine I was here, at this point here, the y-intercept. Okay. At the y-intercept, both Charlie and Dennis are making drinks. Moving from the y-intercept to the point of complete specialization, one of the people has to give up making a certain number of drinks in order to bash rats, right? And who would you rather assign to bash those rats? Charlie, because Charlie has comparative advantage. So from here to here, you have one slope, and then from here to here, you have another slope. Okay, and I've told you that the slope corresponds to the opportunity cost of the x-axis good, rats. But why does it do that? Why does the slope correspond to the opportunity cost of the x-axis good? Because going from here to here, Charlie gives up rats, right? I'm sorry, Charlie gives up drinks to bash rats. Charlie gives up drinks to bash rats. And then going from the point of complete specialization to everybody's making rats or bashing rats, Dennis is giving up drinks to bash rats. Okay, so you should have two opportunity costs, both corresponding to the opportunity cost of drinks per rat, the drinks you're giving up to bash a rat. Okay, and it should start with Charlie's opportunity cost because Charlie's the first one to bash rats. He's the first one to make the trade-off between drinks and rats. And then it should go to Dennis's opportunity cost because Dennis then will give up drinks to bash rats. Okay. If the graph were turned around, if it were like drinks on the x-axis and rats on the y-axis, then it would be completely flipped around. Then it would be Dennis's opportunity cost for drinks, because Dennis would be the first one to make drinks, and then Charlie's opportunity cost for drinks. But obviously it's not. It'd be one divided by that. It'd be the reciprocals. Anywho, so it's always the opportunity cost of the x-axis good. The left portion is always going to be the person with the lower opportunity cost, okay, with the flatter slope, because lower opportunity cost, the opportunity cost of slope should mean that the slope is flatter, okay. This will be the higher opportunity cost with a steeper slope, okay, aka the person who doesn't have comparative advantage in that good. Okay? That's why the slope is steeper, because if you don't have comparative advantage, your opportunity cost is going to be higher. Okay, so the slope is going to be higher at this point, right? So it all kind of boils together. It's important that you understand this. So it's always the opportunity cost of the x-axis good, and it's always the lower slope up front, and then the higher slope next. The reason it's the lower slope up front is because you want to assign the person comparative advantage, lower opportunity cost, lower slope, to do the thing that they have lowest opportunity cost in, the thing that they have comparative advantage in, the thing that they have a lower slope in, to do that first. So moving from the y-intercept, which is specialized, everybody does one good, to the point of complete specialization, it should be the person who has comparative advantage doing the thing that they have comparative advantage in. So this is moving from both of them making drinks to only Dennis making drinks and Charlie makes rats. And this is both of them making rats, bashing rats. So Dennis is moving from having made drinks to making rats at this point. Okay. I'm not going to talk any more on that. I think I beat that to the point to death, but it is important that you understand it. Okay. So I can add here the slope for Dennis should be -1. His opportunity cost for bashing a rat. And Charlie's is -0.55. Okay. His opportunity cost for bashing a rat. If you had the opportunity cost upside down, okay, or if you assign the wrong comparative advantage, what you're going to get is a graph that looks like this, and that's wrong, okay? So let's say you gave Dennis comparative advantage in drinks, in rats, so the incorrect one. If you gave Dennis comparative advantage in rats, he would do 75. Let me clear this up a little bit. Okay. If you gave Dennis comparative advantage in rats, then the point of complete specialization you would have would be 75 rats, and Charlie would have 55 drinks, and the intercepts would be the same, because at the intercepts they're both making drinks and they're both making rats, depending on the x or the y intercept. So your graph would look something like this. There should be two straight lines. I'll do it one more time. Should have went to art school, guys, so I can learn how to draw. Not confuse you guys. All right, so this should be like stop it. All right, you're getting what you're getting. Nope. Whatever. These should be two lines. There we go, with like a defined point right there. So if this is your point of complete specialization, notice you're inside the other point of complete specialization. Okay, so this is where you give Dennis rats and give Charlie drinks, so you flip the comparative advantages around, you clearly got it wrong. Your graph will look like this versus this, like it'll be bent inwards versus bent outwards. Okay, you don't want a sit-up graph. You don't want someone looking like they're doing a sit-up. Okay, and what's the problem with that? Well, if the PPF, the production possibilities frontier, gives you the efficient and feasible allocations, and you're over here instead of being over here, well, you're definitely feasible in that you're under the line, but you're way far from efficient. Efficiency would be on the line. The only points at which you're efficient are the intercepts, which are in the original graph. Otherwise, you're producing at a lower point for every combination of rats and drinks. Okay. So you want to make sure that your graph isn't shaped like this. It's shaped outwards. Okay. And the way you have that graph, the way you can have that graph shaped like that is if you mix these up, because the steeper slope comes first and the lower slope comes second. That's how you'll get it. So always double check. Okay. At any rate, let's start this graph over. So we have joint, J for joint. You have rats on the X, drinks on, should be rats on the Y, drinks on the X. And the only reason for that is because I gave it in the directions. And what else? All right, so we want the y-intercept, the x-intercept, and then some point of complete specialization. We got the slopes already. So the point of complete specialization, let's start with the y-intercept first. So if both of them spend all their time making rats, how many rats can they bash? So Charlie does 100, Dennis does 75, so it should be 175. 175. Okay, and then it'd be, 55 plus 75. They both spend all their time making drinks. So I believe that is 130. Okay, and then the point of complete specialization is Dennis does 75 drinks. And Charlie bashes 100 rats. So that's when Charlie spends all of his time bashing rats, and Dennis spends all of his time making drinks. Okay. And then again, I said the slope was -1 and -0.55, and they correspond to each person's opportunity cost of drinks, the opportunity cost of the x-axis good, which is drinks. And then if you wanted to check that, if you were so inclined, you could do slope 1, rise over run, and the point is, so 175 is the first rise point, and then 100 is the second. The first run point is 0, second run point is 75. Okay, so I should say slope 1, which corresponds to 0, 175, going to 75, 100, the point of complete specialization. And that'll be it's like I did something wrong here. Oh. Um, Oh, no, I did everything right. The problem is, in this graph, I clearly had it labeled rats and drinks flipped over. So yeah, if it were rats and drinks, it would be negative 55, negative 1. Okay. So good thing I checked. So this is, it is drinks and rats. It's just that I can't take the opportunity cost from 4. All right, so the first slope should be negative 1 then. So that is the opportunity cost of the x-axis good. In this case, it's drinks now, which it should have been earlier. I just flipped the graph around by mistake. So the opportunity cost of the x-axis good of drinks is, should be the opportunity cost of the x-axis good for the person who has comparative advantage in the x-axis good. So who has comparative advantage in drinks? Dennis. What's his opportunity cost for drinks? It's 1. Okay, so it should be negative 1. Okay, so then this one should be negative 1.818. Okay, and that would be the opportunity cost for drinks for the person who does not have comparative advantage in drinks, which is Charlie, and he's got 1.818. Okay, and then we can test that too. So 2, and then bring this bad boy over. Slope 2 is going from point of complete specialization 75, 100 to 130, comma 0, the x-intercept. It's also equal to rise over run. Rise will be 100, 100 minus 0. Run will be 75 minus 130. 100 divided by 55 equals 1.818. That is your slope. Look at that, we got the answer. So that's why it's always important to check, because you might make a dumb mistake like I just did and flip around the axes for no apparent reason. It pays to be careful. So always check your work. All right. So the bar has 20 rats. Okay. And just to remind yourself, Charlie is 100 rats, 55 drinks. Dennis is 75 rats, 75 drinks. Okay. And Charlie has comparative advantage. Dennis has comparative advantage in drinks. Okay. All right, so there are 20 rats. Scenario 1, each kill 10 by themselves. Okay, and then I ask you to figure out how many drinks that how many rats and drinks they'll do. So if Charlie does 10 rats, so that gives him 10 divided by 100 is the hours on rats. So he has 0.9 hours on drinks times 55 drinks per hour. So 55 times 0.9, and I get 49.5. Okay, because he's only got 1 hour total. Okay. Just changing that equal sign because 1/10 is not equal to 9/10. Okay. Another way of doing that is 1 minus 10 divided by 100 times 55. Okay. So like formulaically, you could say time minus rats divided by rats per hour. So you say hours divided by rats times rats per hour. And then multiply that by drinks per hour is drinks. Okay. So if you were to do if you were to write this out like rats divided by rats per hour is equal to rats divided by rats, and then, or you could do rats times hour per rats, because dividing by a fraction is the same thing as multiplying by the reciprocal. So that's just equal to hours, okay? And then you're going to have hours minus hours, and that's just equal to hours. It's just the lower number of hours. And then hours times drinks per hour is going to be drinks, right? Because the hours will cancel out. So that's like the simplified formula. If you wanted a formula, I think it's actually easier to go step by step. Okay. So let's do it. If Dennis has 10 rats and he kills 75 an hour, okay, so 10 divided by 75 is the number of hours he'll spend on rats. So that gives him 10 divided by 75, 0.133. So 1 minus 0.133 is the hours on drinks. So that's going to be 0.8667. And then I'm going to multiply that 1.333. Sorry, 0.8667 times the number of drinks he makes, 75 drinks per hour. Don't like the random capitalization there. All right, times 75 it should be 65 even. If you round it a little bit, that's fine. I don't expect it to. Rounding is fine, in my opinion. Okay, so 65 drinks. Okay. If you wanted to do the abbreviated formula, we could do that too. So you got 1 hour minus the number of hours he spends killing rats, which would be 10 rats divided by 75 rats per hour. That'll simplify to hours, and then we're going to multiply that whole thing. I think there should be one more parentheses, right? Yeah. Then we're going to multiply that whole thing by 75 drinks per hour. Okay. 10 divided by 75. I guess it's going to be the same, so it's 1 minus 10 divided by, oh, no, that doesn't work. How do you graph it? All right. 1 minus 10 divided by 75 times 75. 1 minus 10 divided by 75 times 75. Keeps giving me -9 for random reason because I got the parentheses wrong somewhere. Oh, it's just giving me 1. Okay. 1 minus. Try it one more time because I keep screwing up the parentheses. 1 minus, and then another set of parentheses, 10 divided by 75. Okay. Close that, multiply that by 75. You get 65. Perfect. 65, and the label will just be drinks. Okay, so if we were to fill this bad boy out, this is the first one. Yeah. 10, 49.5, 10, 65. Okay. Now, if they wanted to divide it between the two of them, so there's 20 rats total, and we're giving them some specialization, how would it go? So first you need to ask who kills the rats. You go by comparative advantage. Charlie, he has comparative advantage. Okay. It's important to know that. Okay. So Charlie's equation is going to look like this. 1 divided by 1 minus 20 divided by 100 times the number of drinks he makes in an hour. So that'll be 4/5 times 55. So it should be 44. Okay. Alternatively, you could do it like this. He kills 20 rats per. He kills 100 rats per hour, and he has to kill 20 rats. So that means he's got 0.2 hours on rats. How many does he have on drinks then? 0.8 on drinks. 0.8 drinks. Sorry, 0.8 hours times 55 drinks per hour is equal to 44. Okay. What does Dennis do? He doesn't care about the rats. Charlie handled it all the Charlie work. So Dennis just has drinks, and he has how many drinks per hour? He does 75 drinks. So it should look like this. Charlie does all the rats, and he still has time for 44 drinks. Dennis gets none of the rats and has 75 drinks. Okay. All right, last one. That's not really true, but whatever. Charlie demands that Dennis pay him since Dennis made all the money, whatever. So they're trading 3 rats per drink. Trade 3 rats, per 2 drinks. Okay, 1.5 rats per drink. Okay. And they both want 10 rats at the end. So Charlie trades 10 rats to Dennis. Dennis trades 10 divided by 1.5 drinks to Charlie. And what is 10 divided by 1.5? 5. So he gives him 6 2/3 drinks. Charlie trades 10 rats to Dennis for 6 2/3 drinks. Dennis trades 6 2/3 drinks to Charlie for 10 rats. Okay. So they're both going to have Let's actually unpack this one first. So Charlie had 20 rats, gives away 10. Now has 10 rats. Charlie had 44 drinks, now has 44 minus 6 and 2/3. Was that 44 minus 6? 37 and a third. 37.33 drinks. Okay. Dennis has 0 rats. Now he gets 10. Dennis had 75 drinks. Gives up 6 and 2/3. So 5 minus 6.66. So now he has 68 and 1/3 drinks now. So this should be 10, 10, and this should be 37.333 or 37 and a third and 68.33. Oh, I'm sorry. Charlie gets back drinks. So he should gain drinks. So he should have 44 plus 6 and 2/3 drinks. So that'll be 50 and 2/3. Okay. So Charlie gains drinks because he gives away rats. Right. So that makes sense then. There's some now kind of explanation questions. Would Charlie and Dennis choose to divide up the work if they could? Yes, because they could specialize and get gains from trade. If so, explain why. If not, explain why not. Like I said, because they can get gains from trade. Looking at the final allocation, 10 and 10, and so if I'm comparing this one here, when they're working alone versus working together, they both end up with 10 rats, but they both make more drinks. 49.5 versus 50.6, and 65 versus 68.3. So they both get more working together than working alone. The reason that they can get more is because there's efficiency gains from having complete specialization, or not just complete specialization, but specialization that allow them to produce more of each good, okay, based on their comparative advantage. What is the range of acceptable prices that Dennis and Charlie would both accept? Okay, so if I were to draw out this here, okay, and on one hand we have, and I asked for rats per drink. So let's say I had a number line, rats per drink, and this corresponds to the price, the number of rats you have to give up for every drink. Okay. So what is Charlie's opportunity cost of rats per drink? Oh, oops. Charlie's opportunity cost of rats for every drink. Forget off the top of my head, so let's go back up. Let's go back up. All right, so Charlie gives up, for every drink, Charlie gives up 1.818 rats. 1.818 rats per drink. Dennis gives up 1. Okay. Everything in between their opportunity costs. I know I went a little over there, but it should end here. everything between their opportunity costs is an acceptable range that would benefit both. At here, which is Dennis's opportunity cost, it only benefits Charlie to trade. At here, which is Charlie's opportunity cost, it only benefits Dennis to trade. Why doesn't it benefit Charlie to trade when the price is his opportunity cost? Because basically what that's saying is with an extra unit of time, Charlie could make the same rats per drink that he'd be getting back from Dennis. Okay. Or vice versa, the same drinks per rat. Okay. So because he could do it himself with the same exact price scheme, his internal price would be like his opportunity cost. It doesn't hurt him, but it doesn't benefit him either to trade at exactly his opportunity cost. Okay. At this point here, so everything here above Charlie's opportunity cost will be really cool for Dennis, but Charlie wouldn't want to do it because then at this point he's giving up more, or he's trading more rats per drink than he could do himself. Okay, than he could get himself. Okay. And then same thing here. At this point, Dennis wouldn't want to trade. Okay, because then he'd be giving up more, he'd be getting less rats per drink than he could do himself. Okay. And then, so everything in between, there are gains from trade because of specialization. Okay. So anything between 1 and 1.818 will lead to benefits by dividing up the work. So that's the range 1 to 1.818. Okay. Just trying to think if I missed anything. No. And one more point, that's what we call the law of comparative advantage. Okay. For every, as long as the opportunity costs are different, there exists at least one price that will benefit both parties, and hurt neither party. Okay. All right, so that's it for that question, and then we're on to the last mega question. All right, consider the market for milk. The demand and supply of milk are given as follows. So price equals 25 minus QD. Price equals 3QS plus 10. One thing that baffles me, and I don't know why you guys did it this way, because you would have only seen it once in lecture, and you would have seen the other way a lot more in lecture. So I don't know why that is the common one that people go to. But a few of y'all went ahead and did this. You did 25 minus P equals QD, and P minus 10 equals 3QS, which implies that P divided by 3 minus 10 divided by 3 equals QS. Okay. And then you solved it. And there's nothing wrong with it as long as you got the work correct. Some of y'all messed this step up, which is actually problematic because you added extra steps and then you messed them up and then that threw you off. But there's nothing wrong with this. It's just extra steps that don't actually give you anything. You're just rearranging the same equation where you could just have solved it. Okay. So what I want you to do is do P equals P or P star, QS equals, QS equals QD equals Q star, okay? And then solve it like a system of linear equations. P star equals 25 minus Q star, and P star equals 3Q star plus 10. And you could solve it however you would the system of linear equations. You could rearrange it, but it's just extra steps. There's no real need for that because P is already solved for. Okay, so what I would do is I would say P star equals P star. So 25 minus Q star equals 3Q star plus 10. And this is something you should have seen in the lecture a couple times now. Okay, and then I would solve for Q star. Now that I factored out P star, now you have one equation with one unknown. Okay, so I would subtract 10 from both sides, add Q star to both sides, you get 4Q star plus 15. I did something wrong. I forgot the 2 here. So see, when you add steps, you make mistakes. Okay, so I forgot the 2. All right. So this should be minus 2Q star. So I'm going to add 2Q star to both sides. All right. And then Q star equals 15 divided by 5 equals 3. Okay. And then, let's say you screwed up to that point. What you do is you check it. Okay, so you need to find P star anyway. And you can plug Q star into either equation to find P star. So let's plug it into the demand equation first, just because that's the first one that I listed there. 2 times 3, so I should get 19. All right, if I screwed up till this point, it's whatever. What I can do is I can check it, and I showed you how to check it in lecture, right? So you check it by throwing it into the other equation. So I'm going to plug Q star into the supply equation now. 3 times 3 plus 10. And I get the same result, 19. Okay, so what does that mean? It means with both equations, my system is consistent. I get the same answer. So I get Q star equals 3, P star equals 19. Okay, I have my equilibrium price and quantity now. All right, so that's the answer to question A. What about question B? I want you to graph it. Okay, always quantity goes on the X, price goes on the Y. Always demand should be sloping downwards, supply should be sloping upwards. And then we know the equilibrium quantity and the equilibrium price. So equilibrium quantity is 3, equilibrium price is 19. So I've got supply and demand curves graphed and labeled. I have the axes graphed and labeled. I have the equilibrium price graphed and labeled. Equilibrium quantity graphed and labeled. Okay. Now I need the producer surplus, which is always going to be the area between the supply curve and the equilibrium price. So that'll be this triangle over here. I want to be more explicit, like this. Okay. And then consumer surplus is going to be the difference between demand and price, the willingness to pay minus price paid. So it'll be that triangle here. All right, and then what do I need? I just need the intercepts, right? I think I got everything else. So what's the y-intercept for supply? Well, you can look at the equation and you can see that, right? So remember, y equals mx plus b is slope-intercept form. Okay, y equals mx plus b equals slope-intercept form. Y is p. X is q. So your slope-intercept form will look like this, right? Because the p is on the y-axis, q is on the x-axis. Okay, so what's the intercept for an equation that looks like this, P equals 25 minus 2Q D. Okay. The intercept is, if we rearrange, we can rearrange as negative 2QD plus 25, if it's easier. So negative 2 is your slope, the intercept is 25. Okay. And that's your demand equation. So the intercept is 25. What's the intercept for an equation that looks like this? P equals 3QS plus 10. Well, 3 is your slope, 10 is your intercept. 10. Okay. And then you got everything. You have your supply and demand, your y-intercept, your axes, equilibrium price and quantity, and consumer and producer surplus. Okay. I'm just going to make this explicit for your sake. I took it either way. If you labeled it as Q star, if you labeled it as 3 and 19 and whatever. But P star is equal to 19, Q star is equal to 3. You would have solved that in this one here. So whatever you labeled, I took points for. And this is the equilibrium right here where they intersect. All right. So next up, I asked for the producers, consumer, and total surplus. Okay. So consumer surplus is willingness to pay minus price paid. Okay. AKA, it's the area under the demand curve above price. Okay. It's this little triangle that I marked off from the last question. Okay. So what's the area of that triangle? CS equals 1/2 base times height. That's the formula for area of a triangle. Okay. What's the base? Starts at 0, goes to 3, so the base is 3. What's the height? Starts at 19, goes to 25, so it's 25 minus 19, that's 6. So you should have 9. Producer surplus is also a triangle, so it's also going to be 1/2 base times height. And it's going to be the area between the supply curve and your price paid. So from here to here, this little area here. Okay, so 1/2, and the base is also going to be 3 because it's gone from 0 to 3. And what's the height? 19 minus 10, so it'll be 9. Okay, and that'll be 13.5 if you do the work. Total surplus is going to be consumer surplus plus producer surplus. 13.5 plus 9 plus 22.5. Okay, easy peasy lemon squeezy. I say that, but I'm sure some of you probably had difficulty with that. That's fine. Just understand where you went wrong. I think some of y'all mess up these y-intercepts and forget that they exist, and it's important that you don't do that. It's like a common trap I've seen, but it's an important thing that you shouldn't miss. Okay? Because you can't just, like, this doesn't just go to 0. It very much has a y-intercept, even though I'm bad at drawing it. All right. Now we have a new supply equation. Solve for the new equation. Okay, so which happened? Okay, this is up here. Solve for the new equation, or solve for the new equilibrium, I should say. So I'm going to delete out these extraneous steps. All right, and you should have seen this a couple times, so I'm going to go a little faster. But now this is 15. Now this is 15. Now I'm just replacing the number 10 with 15. So then I'm going to subtract 15 from both sides, and now this is 10. Now this is 10, and now 10 divided by 5 is 2. Okay. And then new quantity, so I'm changing this. So I'm changing what we plugged in. So 25 minus 2 times 2 should now be 21. 6 plus 15 is 21. So your new equilibrium price is 21. New equilibrium quantity is 2. Okay. I did that fast, but I can because I know that when I check it, if it works, then it works, then it's right. Okay. All right, so then solve for the new consumer and producer surplus. I think it's more helpful to solve it after I've graphed it. So let's do this. Let's take out this. So I do ask you to draw the curve. Okay, so the new supply curve is S prime. Okay. Old demand curve. So new equilibrium price. So this should be 2 quantity, 21 is price. Okay. So now that we know that, we know that our base is now going to be going from 0 to 2, both supply and consumer and producer surplus. What's the new height for consumer surplus? It'll be 25 minus 21, because now it's this small area here. That'll be 4. So now I have 1/2, 2 times 4, which is 4. And then the producer surplus is going to be this area in here, so 25 to 15, or sorry, 21 to 15. So the new height is going to be 6. Then I have 1/2, 2 times 6, which is 6. And then we're going to have total surplus is 6 plus 4 is 10. Okay, so that's your new total surplus. 6 plus 4 is 10. And then I've already answered F, so I've already graphed and labeled everything. Your new producer surplus, I don't ask you to redraw it, but new producer surplus is this, your new consumer surplus is this. Your old producer surplus was this. Your old consumer surplus was this triangle here. It's a little messy, so don't worry about it. So I don't actually ask you to draw the new consumer and producer surplus. Okay. In words, explain why going from 10 plus 3QS to 15 plus 3QS is a decrease in supply. What I'm trying to ask, and I know that this doesn't always come across, so I kind of accept the range of answers for this one, is if this was your old supply and this is your new supply, S2, S1, right, and this is your demand, why is it that the equation form of adding 5 to the supply equation represents a decrease in supply? Is because when you add 5, you're increasing the intercept, okay, from 10 to 15. Okay. So basically, the willingness to supply, or the cost for every producer, has gone up by 5. Okay. So for every price, the quantity that producers want to produce is lower. Okay. So you could either say that the cost is higher, or that for every price, the quantity supplied is lower. Okay, that's kind of what I'm asking about. But I accept the range of answers. The idea, though, is that for every quantity, or for every price, there's a lower quantity offered. All right, so I'm not going to graph these. Well, I guess I will. Never mind. Q, P. Oh, sorry. Supply, demand. Okay, I ask you, does the demand shift, does the supply shift, do both shift, and what, in which direction? It bugs the crap out of me when I see people do double demand shifts, like demand 1 and supply 1 for every answer. at this point, so I know that I said in the first lecture because I've seen it so many times. I say sometimes the demand and supply will shift at the same time, but it's not always going to be the case. More often than not, one is shifting. At least in this class, more often than not, one is shifting and the other is stationary. And you kind of got to figure it out just by the way that I phrase the questions. Sometimes it can be the case that both are shifting. That happens in the real world, but it also happens in the real world where one is shifting. But then I give you similar questions on the quantitative assignments. I give you similar questions on the practice. I give you similar questions on the, the practice or whatever. So you've seen it a couple times. It's on you to understand, to go back into the answer key and understand that it's not always going to be the case that both are shifting. In fact, I don't think in the homework in quantitative assignment 2 that both of them shifted at any point in time. I think it was always one shift. I'm pretty sure I said specifically that I wouldn't be giving you double shifters, but that it was possible when I introduced these in lecture. But whatever. Okay, so just be aware of that when you're doing your assignments. It's possible that you might see one that has a double shift, but it's unlikely. Okay. Or I shouldn't say it's unlikely, but it's not always going to be the case. It's not everyone doesn't need to shift both supply and demand. The pandemic causes people to want to stockpile milk. What does that mean? It means milk has become more popular because of preference changes, so demand should shift out. Okay, easy peasy. Okay. The shock in the supply chain makes it more difficult to transport milk to grocery stores. What does that mean? Input costs have increased. What happens when input costs increase? Supply shifts in. Okay. That one's straight off from the slides. So far, no double demand shifts. Okay. Quantity on the X, price on the Y, demand down, supply up. All right. Now I want to see this shift. The population of people who can consume lactose decreases. So there's a population decrease. Demand should shift in. Okay. We find out cows can get COVID and a large number of cows die. So essentially, this is another input cost increase. Or you could just say that it's impossible to produce at the same supply. So the supply should shift in because you have less cows to produce the milk. This would be one of those cases where it'd be beneficial to have other people in the section so that we can talk about what threw you off on these ones here. But none of y'all joined, so whatever. The pandemic causes a decrease in American incomes, and milk is a normal good. What does it mean to be a normal good? Excuse me. A normal good is a good that you consume more when your income increases, and you consume less of it when your income decreases. Okay, so there's a decrease in American income. Milk is a normal good. You're going to consume less. Your demand should shift in. Easy peasy lemon squeezy. That should be right from the slides. In your practice. Okay. In order to decrease grocery stores, people use milk substitutes that have a longer shelf life. Okay. Y'all should drink Ensure. Ensure is great. 160 calories, 16 grams of protein. Ensure did not sponsor this video, but it's great. I love it. 21 vitamins and minerals. I don't know why I have all the Ensure nutrition facts off the top of my head, but I drink it often. It's great. The demand is downward sloping. Supply is upward sloping. As a bad supply line, but it doesn't actually have to be a straight line. It's just how I draw it in this class. Whatever. Anyway, people use milk substitutes that have a longer shelf life. So you're consuming more of a substitute. So demand should shift inwards. Boom. I like it when you draw the arrows. You don't have to draw the arrows, but it should be clear that based on the directions, I did ask you to draw the new demand D prime, new supply S prime. So if you didn't draw the arrows, it should be clear that your demand is shifting inwards. All right, that's the midterm. I'm going to cut it here because I think I'm like 15 minutes over. So I'll try to make the lecture a little bit shorter. If you have any questions after having watched this, let me know. Otherwise, have a good week. Study this. You're going to see it again on the final. And these terms, these topics are going to continue, particularly consumer surplus, demand and supply shifts, and finding equilibrium are going to be, they're like the new normal for this course. You'll see them in every lecture here on out. All right. Bravo. Have a good day. Bye.